Welcome to another video of Advanced Higher Maths. In this video, we'll be looking at how to split fractions which have repeated linear factors in the denominator into partial fractions. So, first of all, what do we mean by repeated linear factors? Well, for example, x minus 1 squared is a repeated linear factor. X plus 2 cubed is also a repeated linear factor. So any linear factor, which means it's the highest power, so the degree is 1. And then if it's to the power of something greater than 1, that means it's repeated. So let's look at an example so we know the general format for it. So 3x squared minus 6x minus 13 divided by x plus 3 x minus 1 squared. And this is equal to a over x plus 3, right? That's just the basic, x plus 3. And now this repeated linear factor, well, how does it work? Well, it happens to be that we put it, first of all, in the first order, then in the second order, right? So, say it was to the power of 3, then we have b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed, right? So we need one term for each power ascending each time, if you see what I mean by that. So, let's look then at how to solve this fully into partial fractions. So we've done the first step now, but thanks to this, of putting everything, putting under a sort of equation format here. And now the next step is to put it all under one denominator. And so the way we're going to do this is by making sure every denominator has all the factors. We can combine this into one denominator. So this is a bit more tricky than with the other cases, putting it all in one fraction, but it's still very easy. So the way I think about it, and you probably should too, is what factors is the denominator missing to have all of them, right? So the factors we'll want is x minus 1 squared times x plus 3, right? If we get that, then we have all the factors. So the first one is missing x minus 1 squared. So it's going to be a times x minus 1 squared, so it gets to the x minus 1 squared level in the denominator. X plus 2, x minus 1 squared, so now we've got all the factors here. X plus 3, sorry. Then this one is missing one of the x minus 1 terms, because it's only got x minus 1 to the power of 1, we need the power of 2. So it'll be x minus 1 and the x plus 3 term, divided by x plus 3, x minus 1 squared. Forgive my squint writing. Plus c is just missing x plus 3. So c x plus 3 divided by x plus 3 x minus 1 squared. And now we can just put this all into one fraction. Now I'm going to just cancel it now for the sake of the length of rewriting this all. I'm sure you'll have understood the process by now and understand this means that 3x squared minus 6x minus 13 is equal to a times x minus 1 squared plus b x minus 1 x plus 3 plus c x plus 3. And now you'll see that we can solve for two of the values very easily, and that is a and c, sorry. We can get rid of them very easily at the very least, which will simply be done by substituting values, say x equals 1 to start with. That's getting rid of this one and this one, right? Because they both become 0, because they both have the x minus 1 brackets. This means this is equal to 3 minus 6 minus 13, which is equal to minus 16. So negative 16 is equal to 4c, which means that c is equal to negative 4. Now we can cancel these two brackets by putting x is equal to negative 3, which is going to isolate this one. So this means this side is going to be 927 plus 18, which is 46, minus 13, which is 33. Correct me if I'm wrong. Correct me somewhere, I don't know where. In fact, is it? Wait, 27 plus 18. No. Never mind what I said. I mean, it's equal to 32, because that's 45. Yeah, it seemed a bit weird. 32. So 32 is equal to, now negative 3, so this is, this is cancelled, this is cancelled. Negative 3 minus 1 is negative 4, squared is 16, that's equal to 16a. Thankfully, that's not 33, otherwise it would have been a very nasty fraction. This means that a is equal to 2. And now we're going to substitute these values back into here, and then compare the terms. So 3x minus 6x minus 13, and expand in brackets, all in one go preferably, times, well, okay, not all in one go, x minus 1 squared plus b x minus 1 x plus 3 plus c, that's minus then, minus 4 x plus 3. Now let's expand all the brackets. So we get 3x squared minus 6x minus 13 is equal to, so x minus 1 squared is x squared minus 2x plus 1. So multiply all those by 2, we get 2x squared minus 4x plus 2. Now x minus 1, so b x squared, you can go slower through the brackets if you want, but for the sake of time I'm just going to go through them pretty quickly, as I assume you're pretty good with brackets. And it's going to be plus 2x, so plus 2bx minus 3b, and then minus 4x minus 12. So now we can compare the terms. So we're going to compare the x squared term, and the coefficient's 3, so 3 must be equal to, so we have 2 here, and then we have plus 2b, which means that 1 must be equal to 2b, which means that b, in fact, no, 3, a plus b equals 3. This shouldn't be 2b here. That should just be bx squared. So this is 1 is just equal to b instead, which means, so yeah, 1 is equal to b. So now we know all the unknowns that we need to know. And so plug them back into our original equation here. A over x plus 3, that's 2 over x plus 3, plus b over x minus 1, so plus 1 over x minus 1, plus c, so that's minus 4 over, and then x minus 1 squared. So well done, you've just solved your first repeated linear factor problem, and now I'll give you a practice problem to try by yourself, and then I'll go through its answer. So the practice problem is going to be to express 3x squared plus 2 divided by x minus 1 squared into partial fractions. So press pause and have a go. I'll remind you once again, it's incredibly important to try the questions. That's the only way possible to learn maths. You won't learn maths by just listening to videos and just reading books and watching things. You need to actually actively problem solve. So anyways, enough blabbering. I'll go through the answer now. So the first step is to find its equivalence, which is a over x plus b over x minus 1 plus c over x minus 1 squared, right? Because we're going up in powers for the linear factor. Now we're going to put it all under one fraction. I'm going to skip quite a few steps here. You'll start understanding how to transform these quickly into an expression like so. This is going to be a times x minus 1 squared, because that's the factors that's missing, plus b times x minus 1, plus c times x, right? If you don't understand how to go from here to here, take your time and do it nice and slowly. This means now we need to plug in a value of x. So let's plug in x equals 1 first of all, which is going to get rid of these two terms. So this means that 5 is equal to x, right? To c, 5 is equal to c. Now let's plug in x equals 0 to get rid of this and this. That means, so 0 minus 1 is negative 1 squared is 1. So a here, and that's equal to 2, because 3x squared is when x is 0 is equal to 0. So a equals 2, c equals 5. And now we're going to compare terms. So if we expand all the brackets and plug in our values for a and c, so a is 2, x minus 1 squared is x squared minus 2x plus 1, so we multiply all of those by 2, we get 2x squared minus 4x plus 2. Now x times x minus 1 times b equal to bx squared minus bx, and then always just plus cx, and c is equal to 5, so plus 5x. Now it's very easy to compare terms. Let's compare them for x squared. So 3, the coefficient must be equal to 2 plus b, which means that b is equal to 1, and so plugging back into here, a over x, which is 2 over x, plus 1 over x minus 1, plus 5 over x minus 1 squared is the final answer. So, hopefully you enjoyed splitting more things into partial fractions, and next we will look at how to deal with the numerator of the fraction being higher than the denominator of the fraction. See you then.